Hi, this is Alexi Karve. Today I will be demonstrating the Hugging Face demo with OpenShift data science pipelines. So what we are going to do today is we are going to train this parameter efficient fine-tuning model. We'll use this as our base model and fine-tune it with the Twitter complaints dataset. So that will be the first part of our pipeline. And once the pipeline is trained, then pipeline completes training, we'll upload the model to Hugging Face, which I've already done over here. So once this model is uploaded, then I will use this model for performing inferencing. Okay, so all of this is going to be done through pipelines. So I will show you how all of this is completed in RedHat OpenShift Data Science. So I will go to the OpenShift Data Science page now. So on this page, you can see the request that I'm going to give. So this is the text that is going to be there, which says that I have no water and the bill is paid. Can you do something about this? So this is a complaint. Okay, we want to see if it comes back with the correct answer for this one. What also I have done is that I'm running this in the Hugging Face namespace where the model is going to be present. And since this is going to do training, I'm going to change it to 100 epochs. And when I save the model, I'm going to publish it to my Hugging Face ID, which is this one. Okay, and this is how I actually ran this. I've already run this. This takes about half an hour to complete, at least the training part of it. And once the training is completed, then I have this image that I will download for inferencing and I will test it. Okay, so this thing says the test served LLM model is true, and that's why the testing will be performed. So let's see how all of this is looks like in the pipelines. Okay, since I've already run this, I will just go to the main pipelines page. This is the one that we were looking at today. So if you look at this published pipeline, you'll see, there are these multiple steps. So the first step is basically prompting, then it actually deploys it. And once it is deployed, then it serves the model using the K-serve. Okay, so the deploy is actually going to create the serving runtime. And then this is going to actually do the inferencing part. And once the inference pod is created, this one actually sends a gRPC request to this server and returns a response. Okay, so what I'm going to show you is first the outputs for this first step, where we are going to publish the model into the Hugging Face. Okay, so I have already run this first step over here in these pipeline runs. So I'll show you what happened in the pipeline run. So this was one of the runs that was completed. Okay, so since that has already executed, if I look at this one, this unfortunately doesn't show the logs or any other details over here. Okay, so what we'll do is we'll actually look at the logs using the command line page over here. But this is the full output of the pipeline run. If you look at all the pods that were created over here, okay, I'm getting the inference services, the serving runtime. So the first part of it, what it actually did was it did the creation. Okay, so this prompt tuning part, this was the first thing that got executed. And when I ran this first part, let's say with only 4 epochs, okay, so this is the output after 4 epochs. You can see the training loss and the evaluation loss and so on. Okay, you can see those details over here. And if we give this tweet, if you try to get the output, okay, and the output actually came from this particular thing that was completed. Okay, so if you actually run this prompt tuning and do the test, then this is the last step, in that whole pipeline. Then it comes back with this result over here. Can you do something about this? It says label no complaint. Well, that did sound like a complaint, so it didn't do too well after just 4 epochs. But the same thing, if you go for 100 epochs, this is the type of output you get. Okay, so in this case, I completed 100 epochs, and you can see, the loss is quite low now. And at this time, if you give the same request, I have no water, can you do something about it? It actually comes back with the label of complaint. Okay, so it understands this is a real complaint. So what I'm going to show you now is, that in each of the steps, what actually happened. Okay, so in the first step, basically, what we did is we created this pipeline run. Okay, so we had defined the pipeline, and this pipeline started. As a part of this pipeline, we first created this prompt tuning. Okay, and this prompt tuning is what took about almost half an hour to complete the training. And this half an hour was for 100 epochs. Simultaneously, I also checked this condition. This condition was testing, if I have asked it to complete the testing part of it. Okay, so this will come back with the answer of true. I can check the log for this. And you can see as the pod started and completed, you can see all the details over here. So initially it was pending, then it became initialized, ready, then the steps completed, executing. Okay. And if you look at these steps and you want to check the outcome in the results, you can see that the outcome is true. Okay. So value is true. So this is the outcome of that one particular pod, which was this condition 1. Okay, so we saw condition 1, we saw output of this prompt, we saw output of the test. Also, let's see what this deploy custom runtime does, and then this is the ISVC that it gets deployed. So the custom runtime which is there, okay, what it creates is this particular serving runtime, PEFT model server. Okay, and these two that you see over here, they are available by default. Okay, so I'm not doing anything special over here. These two are already present. You can see the OpenVINO with GPU is also present, but of course it was not able to run our models. Okay, so just as a side, these both are now available in this latest version of rods. But what we are interested in right now is this particular one, okay, which is the ML server. And if you look at this particular serving runtime, you can see all the details. There were some changes I had to make over here, like this ML server root path. I had to set it to /temp. The default path, which was the /root, is not writable. So once I set this to /temp, put the metrics, envs also over here, then it started working. You can see, the model ID that I submitted was this think ahead with the Hugging Face. Okay, so this think ahead is in my namespace, and this was the model that I had uploaded. This was the pre-trained path, okay, the Bloom 560. This is the base model that we took, and then we put that Twitter dataset and trained it further. And the model name itself was the PEFT model. Okay. Okay, so this was the image that we picked up. Okay, that was the other part of it. This was the base image that we pulled, and then this is where we are going to serve the model. So that was the custom engine itself. The other part is what do I want, what model do I want to run in this? Okay, so that comes from let's look at it, ISVC. So the ISVC was this one, PEFT demo. So let's edit that. So this is the ISVC, which is the inference service. I'm telling it that it needs to pick up the connection from here, and this is the default sklearn, so it starts up at least one default inference service. If I don't put something valid over here, it dies. Okay, it doesn't work. So I had to put this, although I am not really running sklearn mnish joblib. Okay, I had to actually create it and push it into our AWS connection, which is the S3 local bucket that I have created. But after that, I don't think this is actually used. Okay, but I still had to create that. Otherwise, it was giving errors. The actual model that we, of course, used was the model that I showed you on Hugging Face. Let's look at some of the code that is present over here. Okay, so the one that we actually created was this pipeline. There are two of them over here. Okay, one is the tuning serving, which only does the serving part. It does not do the training part, but we are just going to look at this pipeline. It does both, okay, the training and the serving. So to generate this YAML, what I did is I have this prompt tuning pipeline Python file. So if I do vi prompt tuning pipeline.py, okay, so then this has all these definitions. One is the prompt tuning bloom. Okay, so this is where the actual training happens. It picks up this Twitter complaints dataset, and it shows that you're going to have a text and a label. It loads the dataset, and then it does the tokenizer, loads the data in the data loader. From pre-trained, it picks up the model that we had provided, gets the PEFT model, shows the trainable parameters, and then for the number of epochs that we have provided, it is going to enumerate through the samples and complete the training. And once the training is completed, it's going to log into Hugging Face and upload the model. Okay, upload meaning push that particular model to the hub. Okay, so that was the first part in this pipeline, which was this one. Then the next one is to deploy the model mesh custom runtime. Okay, so what we are actually doing is we are taking this kind serving runtime, and this is the manifest that we are actually going to create. So you already saw that manifest. What we did is we passed some additional parameters, as I mentioned before. Okay, these were 3 additional parameters that I added so that it wouldn't give errors when writing to the local path. So this was the second step. And then we did the serving with this model that we had. So this was the ISVC inference service. And this was the default I provided, so it would start without problems. And then this was the test model mesh where it gave a request for the inferencing, and then it came back with the actual results. This is the result that we saw. Okay, like for the case with 4 epochs, you can see this is the inference result that we saw. Okay, and with 4, you saw that it had no complaint, but that is not correct. With 100 epochs, you saw that it actually gave the correct result. So all these were just definitions, but this is where the actual pipeline gets created. Okay, so this is our pipeline definition. Okay, so this defines the pipeline over here. So you can see all the 4 main steps or 5 main steps of the pipeline. This is the first one. Then this one depends on each one is going to have a dot after. Okay, so this serving happens after custom runtime is created. The custom runtime happens after the prompt tuning is completed. And you can see that only if the test served LLM model is true, then we will be doing this particular test. Okay. I don't know why this doesn't show a link. This condition, only if this condition is true, then this should get executed. I don't know why it doesn't show that link over here. I would have expected it to show that link, but that is something I'll have to debug and understand a little bit more why it doesn't show that link. And then this Tecton compiler actually compiles this particular pipeline, which we have shown over here, and creates this prompt tuning pipeline.yaml. Okay, so this YAML is what we actually loaded. Let's look at this YAML file now, the pipeline. And you can see this pipeline run that we created. And this pipeline run is what actually is going to get created. When we run this, it will have these individual tasks that will create the task runs, and then that will create the pods. So all of these functions that we have defined, they actually get embedded within this. Yes, you can see all these actions for creating these tasks, and then these task runs are created, and these tasks are then executed. All of this is basically OpenShift pipelines. Okay, so the OpenShift data science pipeline actually depends on OpenShift pipelines, which is the Tecton. So all of these are Tecton task runs that will be executed through the pipeline run. So you saw all these pods that were created over here. Okay, we can get rid of all these pods once they are completed executing. So I can run a watch command over here. Okay, and if I want now this run that we had created over here, I had called it publish to. Okay, I can come over here and I say delete. So now you will see, all those pods went away. Now just the default pods are running. We still have this inference service and this extra serving runtime, so that we have to delete it ourselves. Okay, separately. If you try to run this pipeline run once more, second time, it will try to create these again and it will fail. Okay, so if you want to run the pipeline once more or create a new pipeline run, we have to delete these manually. So I have these two delete tasks over here, delete the inference service and delete the serving runtime. Okay, so that will get rid of both of these. So if you watch over here, you can see that the serving runtime and inference service are gone. Okay, this serving runtime is gone. The inference runtime ISVC was above this, that is gone, and now this pod for the model server is also getting deleted. So this takes a minute or so to get deleted, and this basically cleans up everything that was there. Okay? And if we want, we can always go back and run this, publish. There is of course this flipcoin sample also that we can very easily run. Okay, I'll just quickly create a run over here just to show you, that we can run this one also. I'll just run it with a run one, and we can watch, as this slowly progresses. It started with this flipcoin, and now both these conditions will be executed. Then whichever condition is true, it will proceed past that condition, and each of this is going to create its own pods. Okay, now out of these two conditions, one of them will be successful. Okay, so this one, condition one was successful, so that's why it's going to run the top part of it, this random number, and it will continue, and you will actually see, okay, all these pods for this conditional execution being created over here. So just wanted to also show you, that yeah, we can run the other standard default sample also, but of course this default sample was not available by when we started this. The way to create that sample was actually come to pipelines, do the import pipeline, and this is where I did an upload, and I uploaded this particular prompt tuning pipeline when I created that. But if I wanted, I can go to samples, and there are the flipcoin sample over here, and I was able to upload this condition.yaml. If I wanted to run this particular one, of course, in this one also, okay, I had to compile it initially to create this condition YAML file. I had to run the Python condition.py, and then it was able to do that. Okay, so this YAML file, you have to create it. It's not available automatically. The compiler actually creates that YAML file, and that's the same thing we did with this prompt tuning sample also. Okay, so of course, this prompt tuning sample, if you look at that one, then the first part of it, which was the training part, that is not present, but the second part, which creates the custom runtime and then the actually serves that particular model that we had published to Hugging Face, that part is there, and the testing part is there. Again, in this case, this testing part actually depends on this condition. We don't see that link over here. Don't know why, but that is something that needs to be debugged. Okay, that's it for this demo. You saw the data science pipelines in action. Thank you for watching.